So in this video we will be learning about the types of semaphores. So basically there are two main types of semaphores. One is counting and one is binary semaphores as given in the video. So what are counting semaphores? So they are basically the integer value semaphores and they have an unrestricted value domain. That means they can coordinate and they can count where there are number of available resources. So number of available resources is equal to whatever the semaphores are there. So these semaphores count will be incremented automatically if the resources are removed or the count is decremented. So what are binary semaphores? So they have the restricted value to 0 and 1. So there will be only two values here, 0 and 1. And the wait operation and the signal operation will only work if the value is 0 or 1. So wait operation will work when the value is 1 and the signal operation will work when the semaphore value is 0. So it is easy for implementation of binary semaphores comparing to the counting semaphores. And coming to the advantages of the semaphores, so they only allow one single process into the critical section and they follow the mutual exclusion principle. So what is a mutual exclusion principle? So it is basically a program object that prevents multiple threads from accessing the same shared resource simultaneously. So a shared resource in this context is like a code element with a critical section. So the part of this code that should not be executed by more than one thread at a time. So it will help you for the mutual exclusion and it is more efficient than the other methods of synchronization. And also in the semaphores there is no resource wastage because of the busy waiting in semaphores, and also the processor time is not wasted to check if a condition is fulfilled to allow a process to access a critical section. So semaphores are implemented in the machine independent code of the microkernel. So semaphores are machine independent. So that is one of the advantage. So coming to the disadvantage of semaphore, so there are the following disadvantages. So semaphores are really complicated so that the wait and signal operations must be implemented in the correct order to prevent deadlock. So these both operations are the main operations in the semaphore. And what is a deadlock? So deadlock is nothing but it usually involves like the opposing parties. So where the progress cannot be made. So in any deadlock situation with like no member of some group of any entities can proceed because each waits for another member, including itself also, to take any action. So such as like sending a message or like releasing a lock, like, and so that is nothing but a deadlock. So that is one of the disadvantage. And semaphores are impractical for large scale as their use leads to loss of modularity. So this actually happens because the wait and the signal operations prevent the creation of structured layout for the system. So this is one of the disadvantages of the semaphore, and they may also lead to priority inversion where the low priority processes may access the critical section first and high priority processes later. So in any process, usually the high priority process will be having more priority than the low priority. But in semaphore, in this inversion, you will be having the low priority processes of more priority than the high priority. So that is the reason why semaphores is having a disadvantage in this case. So this is about the answer. Thank you so much.